Hi, welcome back. We are still at chapter 6. So, I'll be continuing my lecture to zero force member. Yeah. So, we are looking at zero force member, which is chapter 6.3 from textbook, page 282. Yeah. So, we are looking at page 282. Okay, so what is zero force member? So, zero force member, if a joint has one or two collinear members and there is no external load or support reaction at the joint, then those two members are zero force members. In example, members DE, DC, AF, AB are zero force members. Okay, so I'm going to show to you what does it mean by zero force members. I'm going to snipe this and put it up on the word. Yeah. Okay, let's look at this. Yeah, let's analyze this. Now remember from my previous lecture, I've actually clearly stated that fx equals to 0 for equilibrium. So how do you achieve this? You achieve this if you have a force to the right and a force to the left with the same value. Yeah, so you can counterbalance and you achieve 0, right? So if let's say in a case of joint A, let's look at joint A. Yeah, so I'm going to draw joint A. Also, I don't have to draw, it's actually down here. Sorry, it's down here. Okay, can you see joint A? You have FAB and FAF. Okay, AB and AF. Okay, so if you were to write fx equals to 0, you only have FAB doesn't even have a partner, so FAB is equal to 0. So which means even without the presence of AB, this structure is actually stable, so you don't even need it. Remember what I told you about being an engineer, you have to optimize in your design and all. So this is actually redundant. Yeah, you're redundant, you can just remove that structure, that particular member. Likewise, you repeat the same thing for Fy equals to 0, and we have this, the top one, and it doesn't have a partner to counterbalance, so which means even without that, this structure will be stable. So I'm going to strike that out again. Yeah, so which means this structure, yeah, this structure will be very stable without this and without this. Okay, now can I do zero force member at point F? Of course you cannot, right? Because there are a lot of external forces here, like this is a pin, so you cannot even do here. Don't even try, don't even think about attempting there. This one also cannot because there is an external force there. What about here? Also cannot because there's an external force. Now E, there is a possibility, but it's going to be complicated because there's 1, 2, 3, 4. So don't even probably you can consider that at the later part of the calculation. So it's a big no for all these parts. No, no, and no. This one probably you can consider later, but let's look at D. Yeah, let's look at D and see if it can achieve the zero force member. So this is point D. So redrawn again, yeah, the same thing redrawn. You have DE pointing this way, and then you have DC pointing here. So this axis is a bit unique because it's tilted. Yeah, it is tilted. So if you see here, yeah, this is tilted. So we have Fy equals to 0. So since that the angle is here, so the opposite one will be sine equals to 0. So if you straighten, if you resolve this to here, you do not have any partner up here, right? So that's the reason why it is 0. The same case, if you resolve this down here to this position, you do not have partner this side. So which means FDE also 0. In another simple word, this structure can exist without this and without this. So leaving behind, the structure will be as simple as what we have seen in the lecture note. It can be just this. So just remember, if this whole structure were repeated about 1,000 times in a construction, so how much you can save with these 4 rods? Let's say one rod is about 100 ringgit or 1,000 ringgit. Just imagine if there is about 1,000 repetitive structures, so there will be about 4 4,000 plus multiply another 1,000. So there's a lot of money. So that's what it's important to determine the zero force member. Okay, let's look at this example. Okay, would you want even to, you don't want to even try attempting here because there is an external force here, right? Okay, don't go there. Don't go here because there's an external force, and don't go here because there's an external force. So this is all big no-no. Big no-no place. Big no-no place. There definitely will not be any zero force member there. So the place that you should look at is D and C. Okay, let's look at D because D is a bit simple. Yeah. So if you look at D, this side, okay, I'm going to use another color here. This side and this side will balance off each other, right? So which means, in another word, this is not needed, right? Yeah, this structure here, no need. Okay. Likewise, if you repeat here at point C, this side balance of this side, and you don't need this. So at the end of the day, this whole structure by calculation will be stable with just this, 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 and this. So this is why it's important to actually determine the zero force member. Okay, so I will show you an example in the textbook itself. Yeah, so this is zero force member from the textbook. Yeah, so let's go through, just read up on it. I'm not going to read because I'm very sure that if I read, you're going to fall asleep here. This is what I've discussed earlier. Let's look and solve an example. Oops, where did the example go? Just make it small. Example 6.4 from the textbook. So this is example 6.4 from the textbook. Yeah, so look at this. So like what I've told you, don't approach A, don't approach E, do not approach C, and do not approach B, because this is where the external forces are. So simplest place to approach is join G. Can you see G? So for G, you have balanced of the left and the right here. So this up one is redundant. That's why it's FGC is 0. Can you see this drawing? This is for point G. Next, you repeat this for point D. Yeah, point D, because D has got three force member. Why didn't you do it at F? Because F got 4 force member. Yeah, always attack the places where there's least headaches. Yeah, remember what I always tell you in the class. So join D. In join D, you will see that DC balances DE. So DF has got no partner. So can I call DF 0? Yes. Okay. Okay. The next one is, so how many places have I strike? Since that this is PDF, I can't actually scribble on the PDF. So you have this striked off. Yeah, sorry. Okay, you have your, doesn't work on that. So let me see. Okay, so you have literally striked off GC, DF, and you do the same thing with point F. So in point F, this is where point F is. So your FD member is 0 already. So which means FE has got partner with FG. Yeah, and then you have FY, which is pointing upward, FC. Yeah, FC doesn't have a friend, a partner. So FC is 0. Okay, so that's how you determine. Okay. Okay, so the next one would be at point H. Let's look at point H. Point H, we have 2 kilonewton from the previous external force here. So HA balanced with HG, so you can't say HC as 0. Yeah, you cannot. It's not a zero force member, because this HC can be balancing this 2 kilonewton. Yeah, so that's the reason why you cannot strike off. So in total, you are striking off GC, DF, and FC. Yeah, 3 force member. Okay, so we have completed subchapter 6.3. So your homework you have to submit at the below link would be redo example 6.4 and submit to the link below. Okay, see you in the next video.